Hello, my wonderful young scientists. I hope you are all doing super duper out there, and that you were able to enjoy a little bit of the snow and sun this weekend. A little odd. That's okay. Today we are going to be talking more about coronavirus and COVID-19. We are going to focus specifically on how it spreads and how we can prevent that spread and why social distancing, which all makes us a little sad inside. It does. I don't love it. But it's still really, really important for us to do. So when you're working on your doc, obviously you're going to click to enter the doc. And then the first thing that I want you to do is notice that the first page, those are just instructions. You don't really have to do anything from this. So I want you to draw a model predicting what will happen and how the virus actually spreads. So let's say day one, oh no, that jerk at the grocery store totally sneezed right in your face hole. Ah, okay. And you're person B. Now what happens? What is the virus doing? To do this, you can either draw it on a piece of paper and take a picture just like we would normally do in class. You can also use Google Draw. To use that, click directly on the picture, click Edit, make it all fancy, you fancy pansies. You can click and add arrows and shapes and all kinds of cool little things if you feel like dinking around a little bit. You can scribble if you just want to go rogue and draw freehand. But yeah, so when you're done with that and it's everything you want it to be, this is everything I want it to be right here, then you are going to hit save and close. The key though is that you want to think about what the virus is doing, right? Not just how sad your face will be because you have boogers on your face. Then you're going to describe what happens. Person A is blank. Person B, oh no, what happens to the viral particles? And then how does it actually enter your body? Because remember, we talked about how your hands and your skin is super protective, right? Not like stuff just like you just absorb pathogens all the time. So how does it actually get into your body, right? That's what I want you to think about for this particular one. The next one, day 3, what do you think would be happening here to this person's body? Now, we know that the incubation time can be 3 to 14 days that you can start until you start showing symptoms. But if we pretend that this is inside of lungs, what do you think is happening to the cell? So what is the virus doing? And how is it succeeding, right? Why is it able to infect so many people? So think about what it must be doing inside of these cells or to these cells for that to occur. Again, you are going to add little word blurbs underneath to talk about why and how things are happening. Next, there are 3 short little videos that you are going to take a gander out, and then you're going to reflect and think about, like, what can I specifically do in my life to stop the spread of this virus? What can I do to make things safer for my family, for myself, and all the people in our community around us? The next thing that you're going to do is go ahead and click on this handy dandy link to the Washington Post. This will guide you towards this super cool website. You do not have to sign in despite what it says, where you can actually look at these really awesome, like, I don't know, simulations of how disease spreads. It's pretty interactive, it's pretty cool, and it shows exactly how we are having the coronavirus spread. So like a sick person is this kind of like rust color. A person who's recovered would be this purpley guy, and it shows you, how that impacts things. So for this first one, the disease is called simulitis. It's punny, you guys. Okay, so we have simulitis here, and then when you scroll down, the simulation will start to run itself. So this particular one is, you can see that the recovered is in purple again, healthy is blue, and the sick is going to be the brown. You are going to use this simulation, you do have to wait till it finishes running, right? So it takes a few seconds. And then you're going to use those numbers to fill out these little charts. So for the first one, for example, free-for-all simulitis spread. They are in order, so that's the first graph. When you are looking at that, you'll do this, you'll wait for a second, and you'll be like, okay, well, there's no healthy people. There's 200 recovered people, and now there's no sick people. All right, so you would write 200, 0, 0 here. Then you can either take a screenshot of this graph specifically, or there is a summary at the end. So you keep on trucking. Does this in a bunch of different scenarios. So it does this with like a forced quarantine. So this one is showing like, okay, well, we have this barrier, but as we release quarantine, since it's impossible to totally like actually quarantine a place, right? Because we have a global society. So food, water, shipping, basic medical necessities. People are crossing borders when they, shouldn't be if they're in this forced quarantine situation. So you're still going to see this spread eventually, right? Then as we go through, it shows what would happen with like social distancing. There's two examples for that. There's one where it's less social distancing and one where there's lots of social distancing. And so you can really see, how those are actually impacted. And so at the end here, you are going to be able to see the difference between this, right? And there are some pretty big differences. And this is what we refer to as flattening the curve, right? And you can see that if everyone were just allowed to do whatever and just went for it, right, we would have a scenario like this versus, I think this is probably more in this moderate area, right? But, us trying to maintain our separation slows down the spread, and it gives our hospitals a chance to keep up with the disease. So even if, let's say everybody was to get the disease eventually, we want them to get it slowly so that people survive in the hospitals, right? We want the hospitals to have a chance to not run out of ventilators. We want to have enough PPE, it's called, so personal protective equipment. We want to make sure we keep people as safe and healthy as possible. And we do that by slowing this down instead of having it all happen at one time. Because if it all happens at one time, it turns into kind of a crisis mode. So those are some really important little details there. And then I want you guys to discuss this little thing. In one crucial respect, though, these simulations are nothing like reality. ... You'll have to keep reading. You probably could do it right now on this screen, but you're going to respond to that. All right. So here, you're going to put in your data on your Google Doc. Then you are going to reflect. And you do have a teensy-weensy little claim evidence reasoning to write. I did put all kinds of sentence starters in for you guys because I was like, if I can't be there to help you in person, I'm going to help you on the interwebs. So here we are. So yeah, I think that's about it. Make sure that for your evidence, you use numbers. That's why I wrote, I know this because the number of ... So that means that you're going to go back up to your little graph up here, and you're actually going to write down some real data. Your data might be different than somebody else's because the simulations run new every single time. So just kind of be aware of that. All right, make sure to stop by either me or during my office hours. Remember, those are Monday, Wednesday, and Friday at 1, or if you just want to hang out and chat, or Mr. Fields on Tuesdays and Thursdays at 11. I miss you very much, my wonderful young scientists. I hope you are all happy and healthy and that you are able to enjoy some of the lovely sunshine that is predicted to occur this weekend or week or whenever it is. I don't know. Every day is the same. All right. Happy Monday, and science is everywhere.